We're explaining the Dang operon in the presence of E. coli that converts D-adenosine N-glucosamine when it is in the rack, when it converts it into glucose when the balls are on the table. We'll be saying that D-adenosine N-glucosamine is Dang. In the presence of high amounts of glucose and in low amounts of Dang, the E. coli cell will initially use the glucose and start to grow. Keep going. Once all the glucose has been used up, the Dang operon will then convert the Dang into more glucose, which will then be further used up. Represented in front is a standard growth curve of E. coli while using spectrophotometry. The x-axis represents time, the y-axis represents ODS 600. The initial stage of lag 1, the E. coli is getting used to the cell environment. It then goes through log 1 where the glucose is being used up and the cells grow. Lag 2 then occurs where the little bit of Dang that's been left over is being transcribed into glucose. That glucose is then increases cell growth. That cell growth then goes through the stationary phase. Initially, the genes were not transcribed because there was already high amounts of glucose. However, after lag phase 2, the rest of the Dang was transcribed into more glucose for further cell growth to occur.
In the presence of low amounts of glucose and high amounts of Dang, these genes are transcribed for more cell growth. So the Dang is converted into glucose to produce more cell growth.
Go ahead.
Okay, in graph 2, with the x-axis showing the time, and then in the y-axis showing absorption, the number of bacterial growth. And the lag phase takes longer because Dang has to transcribe to glucose, which can be used for growth in the log phase. And once the glucose source is being limited, it's being demonstrated in the stationary phase. Go. In the presence of high amounts of glucose and high amounts of Dang, initially these genes aren't being transcribed because of the already high amounts of glucose acting as a primary source of energy. Dang are not synthesized when they are not needed because E. coli conserves cellular resources and energy by not making the Dang yet. Once all the glucose has been used up, Dang is then converted to glucose and is utilized for cell growth.
For the graph of high amounts of glucose and high amounts of Dang, the x-axis represents time, the y-axis represents absorbance and ODS 600. Initially, the first lag phase, E. coli is getting used to its cell environment. In log phase 1, the initial glucose is being used for cell growth. In lag phase 2, the Dang that is left over is being transcribed into glucose molecules. In log phase 2, the second set of glucose molecules is used for enzymatic growth. In stationary phase, the amount of glucose has dropped off and the cells begin to die.
What am I saying? My group consists of Fritz, Colin, and Vivian. Fritz couldn't be here because of personal reasons, so this is our video in the Dang operon.